In this video, we're going to talk a little bit about the transformations of trigonometric functions. You probably have previously learned about how to transform algebraic functions like the squaring function or the square root or the cube root. In this one, we're going to take a look specifically at trigonometric functions. The basic 4 to 6 transformations that occur with algebra functions also occur with trigonometric functions. The terminology changes slightly, but all of the concepts are still there. So you have a generic trigonometric function. We're going to use sine as an example throughout this video. So you would have the equation y equals a times the sine of the quantity bx minus c, and then added to d. And so a, b, and c can each be a different number. And there are two types of transformations. They're the rigid ones. Rigid transformations change only the position of the graph. Your basic shape remains unchanged. The first of those is a vertical translation or vertical shift, which, if you'll recall, is determined by the value d, which is the number that's kind of added or subtracted or tagged at the end of the equation. It does actually tell us whether to move the graph up or down. Common sense tells us if it's positive, we move up, and if it's negative, we move down. The horizontal translation or the horizontal shift moves the graph left or right. In trigonometry, this translation of moving it left or right is referred to as a phase shift. And it's actually the value of that phase shift, how much you move it left or right, depends on whether the value is negative or positive. Obviously, negative goes to the left and positive goes to the right. The quantity is determined by looking at the value of C divided by B. And I have a little trick that'll help you figure that value out. In just a few minutes, I'll show it to you. And then, of course, we have the reflection. And we can reflect, again, either about the x-axis or about the y-axis. To determine whether you are going to reflect on the x-axis, which is kind of like a flip, if the value is negative, you look at the sign, the S-I-G-N of letter A. Remember, AX, you get the ax. So if A is negative, you flip or reflect across the x-axis. Reflection about the y-axis is determined by the sign S-I-G-N of B. And again, B, Y, you get the by. So that's the way to remember it. Okay, so if B is negative, you flip it across the y-axis. We also have the non-rigid changes, which is actually affects or changes the shape of your particular function or your particular graph. It's like a distortion or a morphing. Those include a vertical stretch or shrink, and within trigonometry, we call that change in the vertical stretch or shrink the amplitude or the height. Okay, and it's determined by the absolute value of A. Then you have the horizontal stretch or shrink, which again in trigonometry is called the period. And you can think of the horizontal stretch or shrink sort of like an accordion where you're pumping it in and out. And so either it's going to take you longer to see the entire picture, or it's going to take you a shorter time to see the entire picture. And we determine the period, how long it's going to take us to see a full picture of the curve, by taking the original period or the standard period for the trigonometric curve and dividing it by b. And I'm going to walk you through those calculations in just a few minutes. So again, you got to really pay attention to the position of your constants, the a, the b, the c, and the d, because that's going to help you to determine the type transformation that occurs. And again, honestly, it's the same type transformation that you had for your algebraic functions earlier. Okay, we just use a different terminology for some of those things. So here are the steps that you kind of want to go through when you want to graph the translation or the transformation of a trigonometric function. First, you want to determine the amplitude. 2, you want to determine the period. And for sine and cosine, in order to see the entire sine curve or the entire cosine curve, we have to make a full revolution around the unit circle. So its standard period is 2 pi. So we can find the altered period by doing 2 pi divided by b. For tangent, it only takes half a rotation around the unit circle, and so it would be pi divided by b. Then we need to find where we're going to start, and by finding that start value and the other 4 key points, that lets us put the points that we need on our horizontal axis, and it also determines our phase shift. So kind of a shortcut or an easy way to find your phase shift is to take bx minus c, which is the expression that's kind of usually inside the parentheses connected to your trig function, and set it equal to 0 and solve for x. Once you have it solved for x, that's actually your c over b, and that indicates your phase shift. That tells you where you're going to start, and then to find the other 4 key points that you need, you take the period that you just calculated in step 2 and divide it by 4. Guys, you're going to be dealing with a lot of fractions, so either you may want to have a calculator handy or you're going to have to remember how to deal with fractions, and we'll take a look at that as we go throughout this video. Then you want to find the values of y for the 5 key points. Now, you can kind of do that using the unit circle, but sometimes it's easy to figure it out based on the transformations, and so we'll take a look at that as well. And then you want to connect the points with a smooth curve. So I want to walk you through several examples throughout the remainder of this video, and I'm going to walk through these steps, show you the calculations, and then show you what the graph would look like. We're specifically going to focus on the sine curve for this particular video. So I want to kind of start slow, okay? And so we have the first example is y equals the sine of x plus 2. Okay, so I want us to start out. We need to identify, ideally what we want to do is identify the a, the b, the c, and the d. So remember that a is the number in front of the function. It's out front. So in this case, a is an understood 1. It may help you to realize that there are parentheses around this x. So the b is the number in front of the x, which again in this problem would be the understood 1. There's nothing being added or subtracted from that x. So c in this scenario is 0, and then d is this number tagged at the end, which is positive 2. Now, remember that as we think through this, I'm going to start with the vertical translation. The vertical translation is determined by d. And since d is positive 2, that tells me that I want to go up 2 units. For sine, the traditional period, to find the period, remember it's the original period, which for sine is 2 pi, and we divide it by b. So for this problem, I'm going to have 2 pi divided by 1, which is 2 pi. For my phase shift, I'm going to kind of come off over here to the side for a minute. You take the expression inside the parentheses, which happens to be x, and set it equal to 0, which first of all tells me that there's no phase shift, okay, because x equals 0. 0 would be my starting point when I start to create the graph, okay? Then I need my second point, my third point, my fourth point, and then my ending point. And again, to find those, we take the starting point, okay, plus the period divided by 4. So the period divided by 4 would be 2 pi divided by 4, or pi halves. So if I think about it, my second point is going to be 0 plus pi halves, which gives me pi halves. My third point would be the second point, which is pi halves, plus pi halves. 1/2 plus 1/2 is 1 pi. Then I have pi plus pi halves. So that's 1 whole pi plus a half, or 1.5, which is 3 pi halves. And then my ending point is 3 pi halves plus pi halves, which is 4 pi halves, or simplifies to 2 pi. So the points that I need to graph on my number line for this graph are 0, pi halves, pi, 3 pi halves, and 2 pi halves. Okay, so I'm going to move to the next slide, and I want to try to draw this graph for you. Okay, so I'm going to go to the next slide that's blank, and I'm going to draw my XY plane. Okay, so you got your vertical number line, which is the Y, and your horizontal number line is X. Okay, typically with the sine curve, you have an amplitude of 1. Okay, so I'm going to number these off. Okay, so we're going to start at 0. Then I have 1, 2, 3, 4 additional points. We know that that's going to be pi halves, pi, 3 pi halves, and 2 pi. We could also rotate negatively. Okay, if we subtracted those points, we would have negative pi halves, negative pi, negative 3 pi halves, negative 2 pi. Now, your basic sine curve, just so you can have a sense of how this works, okay, you have the basic sine curve, which starts at 0, ends at 0, and at the halfway point is at 0. It maxes at 1, and the minimum is at -1. Okay, so this would be the basic sine curve. If we go back the other way, again, it begins at 0, it would end at 0, it would mid at 0, it would have minimum first, and then maximum. So this gives you what's called 2 periods, or 2 cycles of the basic sine curve. So the yellow here, just so you'll know, is the good old basic y equals the sine of x without a transformation. So the transformation that we wanted to do here is basically there was no phase shift, the period had not changed, and so we only want to translate it up 2 units. So we have the same points again, our beginning and our ends, but now we're going to move, instead of starting at 0, which is where the sine curve traditionally starts, we got to shift it up 2 units. So now it's kind of like, if you can imagine, you have this imaginary 0 line running through 2, because you're going to take the whole graph and shift it up 2 units. So my beginning point is going to be at 2, my ending point is going to be at 2, my midpoint will be at 2. So let's think about it. If my high point is at 1 and I shift it up 2 units, I'm going to be at 3. If my minimum was at -1 and I shift it up 2 units, I'm at +1. So I've taken the entire curve and I've shifted it up 2 units so that you get this purple looking curve. And then again, this is 2 cycles or 2 periods of y equals sine of x plus 2. Now that's not too bad because you can draw the basic sine curve and move it up. When we start thinking about the phase shift or a period change, then they look a little bit more complicated. Okay, so let's look at another one. This one is y equals 3 times the sine of x. And again, if we start out by identifying A, B, and C, remember A is the number that's in front. Okay, so in this case, A is 3. Again, you have sine x. Remember, the B is the number in front of the x. So in this case, it's an understood 1. There's nothing being added or subtracted from the x. So C here is 0, and D is also 0 because there's nothing tagged at the end. So again, if we think through our transformations here, the amplitude would be the absolute value of A, or the absolute value of 3, which is 3. So basically what we're saying is, instead of it having a height of 1, we're now going to stretch it vertically so that it has a height of 3. The period, we would have 2 pi divided by b. 2 pi divided by 1 is again 2 pi. The phase shift, if we take x and set it equal to 0, it is 0. So here again, there's no phase shift. And because D is 0 here, there is no vertical translation. So I know that my starting point corresponds to the phase shift, which is 0. I'm going to find the second, third, fourth, and my ending point by adding the period divided by 4. So again, I have 2 pi divided by 4, which is pi halves. So we would have 0 plus pi halves is pi halves. Pi halves plus pi halves is 2 pi halves, or simply pi. Pi plus pi halves is 1.5, or 3 pi halves. And then 3 pi halves plus pi halves is 4 pi halves divided by 2, which is 2 pi. So again, that's our beginning and our ending point. And so on my horizontal axis again, I'm going to put 0, pi halves, pi, 3 pi halves, and 2 pi. Okay, so I'm going to graph this on the next slide for you. I'm going to draw the coordinate plane. Okay, so we have our vertical axis, and we have our horizontal axis. That's your x and your y. 1, 2, 3. -1, -2, -3. Okay, so we start at 0, 2, and we're going to end at 2 pi. We had pi halves, 1 pi, and 3 pi halves. Again, we can do that same thing and rotate negatively. And again, I want to show you what the basic sine curve looks like, again, so you can hopefully see the connection. The basic sine curve begins at 0, ends at 0, mids at 0. It normally has a maximum of 1 and a minimum of -1. So your basic sine curve looks something like that. Okay, if we rotate negatively, again, you begin at 0, we end at 0, midways at 0, we min at -1, and we max at +1. And so this again gives you 2 periods or 2 cycles of the sine curve. Again, if we go back and look for just a minute at our transformations here, we got to change the amplitude to 3. There was no change in the period. There's no phase shift and no vertical translation. So basically what happens when you have a change in the amplitude is you don't really move your zeros. Your zeros, you're still going to have a 0 at the beginning, a 0 at the end, and a 0 at the middle. But the height of your curve changes. Instead of maxing at 1, it's going to max at 3 because that was the amplitude. And it's going to min at -3. So you still have your beginning and ending at 0, but you change the height from 1 to 3 because A was 3. So you min at -3. So you get basically the same curve. It just is what we call taller, and I'm sorry I'm missing some of those points, but you get the idea. So this would be the graph of y equals 3 times the sine of x. All right, moving on. This one is y equals the sine of 2x. Okay, so let's look at what all this does. Let's identify A, B, and C. Remember, A is the number out front. So in this case, A is the understood 1. B is the number in front of the x. So in this case, we have B equals 2. There's nothing being added or subtracted to B, the x, so C is 0, and D, nothing being tagged at the end, so D is also 0. So for amplitude, we would have the absolute value of A, which is 1. So the amplitude stays at 1, that's the typical amplitude. My period would be 2 pi divided by B. So I would have 2 pi divided by 2, which is 1 pi. So basically, instead of taking 2 pi or a full revolution around the unit circle, we're going to be able to see the graph in half that time. So you're actually creating a horizontal shrink. You're able to see it in less time. Phase shift, if we take 2x, set it to 0, and solve for x, we did get x equals 0, which again indicates that there is not a phase shift. And here again, since D is 0, there's no vertical translation. So we just determined that our starting point is 0. We need to find period. Now pi divided by 4. Okay, so find our second point. We do 0 plus pi fourths, which is pi fourths. Third point, we do pi fourths plus pi fourths equals pi halves. Fourth point, we do pi halves plus pi fourths. That's 3 pi fourths. And then our end point is 3 pi fourths plus pi fourths
which is 4 pi force 4 pi. Okay. So again, the values that you're going to put on your x-axis are 0, pi force, pi halves, 3 pi force, and pi. Now here again, on the actual graph, I'm going to show you the original sine curve, and then the graph of like sine 2x. Again, I want you to hopefully see what's happening to the curve. Okay, so let's draw the original basic sine curve first. Okay, so we would have our vertical number line, horizontal number line. We start at 0 typically, and then we go pi halves, pi, 3 pi halves, and 2 pi. Okay, and I'm going to go backwards. And our amplitude is typically 1. Okay, and that hasn't changed here. So our basic sine curve is, it begins at 0, ends at 0, mids at 0, maxes at 1, mins at -1. So you would have this curve. Okay, begins at 0, ends at 0, mids at 0, maxes at 1, mids at -1. So again, you have this basic curve. Now, what's different about this particular graph for y equals sine of 2x is that we're going to, instead of taking this 2 pi, it's like we're going to shrink it, and it's only going to take pi units. So we have to fill in the values that we know. We should be using 0, pi force, pi halves, 3 pi force, and pi. And so my beginning is at 0, my ending is at pi, halfway I'm at 0, I still max at 1, and min at -1. So basically I have kind of scrunched the curve together. Okay, if I want to go backwards, again, you can use the negative values. You would still begin at 0, end at 0, mid at 0. You still have the max at 1 and the mid at -1. So instead of it taking us 2 pi, it's like we've pushed the accordion together, and it takes less time to do that. Okay, so you've shortened your period, or the time that it takes to see the full sine curve. All right, the next one. This one is going to involve a phase shift, and then we're going to look at how to put it all together. Okay, so if we're looking at our equation, y equals the sine of x minus pi halves. Okay, a is the number in front of the sine, which in this case is understood 1. B is the number in front of the x, which is also an understood 1. I do have a minus pi halves inside, so C is negative pi halves, and then at the end, D, there's nothing tagged at the end, so D is 0. So the absolute value of A, or absolute value of 1, is 1, so our amplitude really hasn't changed. My period is 2 pi divided by B, so I have 2 pi divided by 1, which is 2 pi. So my period really hasn't changed. And I'm going to skip down to vertical translation. D is 0, so there's no vertical translation. What has changed is I have x minus pi halves equals 0. And if I solve that for x by adding, pi halves to either side, okay, we have x equals positive pi halves. So the fact that it's positive tells me I'm going to shift it right pi halves units. Okay, so I'm shifting right pi halves units. So I know that my starting point, instead of being at 0 this time, is going to be at pi halves. I can still find my other key points by doing the period, adding the period divided by 4. So the period is 2 pi divided by 4, which simplifies to pi halves. So for the second point, I would have pi halves plus pi halves, which is 2 pi halves, or 1 pi. Then I would have pi plus pi halves, which is 3 pi halves. I'd have 3 pi half plus pi halves for the fourth point. So that gives me 4 pi halves, or 2 pi. And then 2 pi plus pi halves. It's going to be 2.5, or 5 pi halves. So everything's shifted pi halves to the right. All right, so let's see if we can take a look at what happens on this particular graph. Again, I want to try to show you the original sine curve so you can hopefully see the difference. So let me see if I can draw this here. Our vertical number line, our horizontal number line. Again, on the y, our amplitude is going to be 1 and -1. That didn't change. So normally we have 0, pi halves, pi, 3 pi halves, and 2 pi. That's our standard. We use those quadrantial angles as the standard numbering if I don't have some kind of phase shift or a period change. Okay. All right, so our standard curve for sine begins at 0, ends at 0, mids at 0, maxes at 1, mins at -1. So you have this basic curve. Okay, begins at 0, ends at 0, mids at 0, maxes at 1, mids at -1. Okay, so there's your good old basic everyday sine curve. Then if we think about graphing the phase shift, it said we're going to basically pick this graph up and we're going to move it pi halves to the right. So my beginning point is actually going to be at pi halves. And then we had pi, 3 pi halves, 2 pi halves, and then we have an extra point out here, 5 pi halves. Okay, and I don't have room, and I don't know if it'll let me draw it over here, -5 pi halves. Okay, oops, looks like I forgot to put the negatives on there. Let me go back so I don't confuse you. Okay, so then once you get those points labeled, okay, your new points for the phase shift, the kind of the green points, okay, then you're basically going to keep the same shape. I'm going to begin at 0, which is pi halves. I'm going to end at 0, which is 5 pi halves. Mid at 0 at 3 pi halves. I'm still going to max at 1 and mid, and then min at -1. So you get this shape. And again, basically all I've done is take that yellow standard basic sine curve and pick it up and move it pi halves to the right. Okay, so if I were doing the negative direction, we would have pi halves, 0, negative pi halves, pi, and negative 3 pi halves. And so if I think about drawing it backwards, again, you begin at 0, we would end at 0, mid at 0, min at negative 1, max at 1. And so here are your two cycles of the sine curve. And this is y equals the sine of x minus pi halves. Okay, so I've kind of shown you each type of translation with the exception of a reflection for the sine curve. And I want us to look at one more example of putting this thing together, putting it all together, doing a transformation, an amplitude change, a period change, putting it all together in one big problem. Okay, so let's first identify A, B, C, and D. A here is 3. B is the number in front of the X inside the parentheses, so B is 2. C is your pi, and then D is negative 1. Okay, so let's walk through the transformations. The amplitude would be the absolute value of A, which is going to be 3. Absolute value of 3, which is 3. The period is 2 pi divided by B. So I have 2 pi divided by 2, which is pi. My vertical translation, which is D, is minus 1. We're going to shift down 1 unit. For my phase shift, I have to do a little bit of calculation. So I have 2x plus pi equals 0. I'm going to solve that for x. So I have 2x equals negative pi, divide by 2, divide by 2. So x is negative pi halves. Okay, so that the fact that it's negative tells me I'm going to go left pi halves. Okay, so I've got to change the amplitude from 1 to 3, the period from 2 pi to pi, shift it left pi halves units, and also translate it down 1 unit. Again, I need to find those 5 key points. So my starting point we've already found is x equals negative pi halves. I've got to do the period, which is pi divided by 4. So my second point is going to be negative pi halves plus pi fourths, which is going to be negative pi fourths. Third point would be negative pi fourths plus pi fourths, which is 0. Third point is 0 plus pi fourths, which is pi fourths. And my end point would be pi fourths plus pi fourths, which is 2 pi fourths, or pi halves. Okay? All right, so let's graph this thing. And again, I'm going to try to show you on the same grid the original sine curve and then the one that we've created. Okay, so let me get my grid drawn up here. Okay, so we normally start at 0. Then we have pi halves, pi, 3 pi halves, and 2 pi. Okay, and we have the same thing going in the other direction. They're just negative. Okay, so your basic sine curve begins at 0, ends at 0, mids at 1, maxes at 1, mids at -1. So you have this curve. Okay, begins at 0, ends at 0, mids at 0, means at -1, maxes at 1. Okay, so here's your basic sine curve. All right, now we need, go back and look, we need to change the period to pi. So we need to have the points negative pi halves, negative pi fourths, 0, pi fourths, and pi halves. Okay, so when we figure these points, the negative pi halves, negative pi fourths, 0, pi, and pi halves, we're taking into consideration at the same time the change in the period as well as the phase shift. Okay, so I'm going to put those points on my grid. Okay, so we're going to use negative pi halves. We're going to use negative pi halves. Then we need negative pi fourths, 0, positive pi fourths, and pi halves. Now, I could do, if I wanted to do that again, I could do pi halves, 3 pi fourths, pi, 5 pi fourths to have that second curve, or we could go in the opposite direction. Okay. We also need to shift the entire curve as we get ready to think about drawing this curve. We've got to shift the entire curve down 1. So I'm going to imagine that my 0 line, if you will, is now at positive or at -1 because we needed to shift down 1 unit. And also, as we begin to start drawing it, we have to think about the amplitude change. So typically, the sine curve begins at 0, but we got to shift it down 1. So really, that's going to be my new 0. So at pi halves, beginning, ending, middle, we're at 0. Normally, we would max at 1 above. Okay, so you got to think about it here. You're going to shift this max point down 1, but then you got to change the amplitude to 3. So we're going to end up right here. Okay, you got to go max normally would be at 1, but we got to change it to 3. Okay, the minimum, again, we would shift the entire curve down 1, but then it's going to change to a height of 3. So this would be y equals 3 times the sine of 2x minus pi minus 1. I think it was plus pi, excuse me. Okay, so I'm going to do it again. We begin at -1. We end at -1. Midway, we're at 0. We should be 3 units above the 0 line. 1, 2, 3, because my amplitude is 3. 3 units below. So you got a lot going on there, and it may be very difficult to visualize. Okay, it's almost easier if you try to draw the graph by hand rather than trying to do it in the calculator because it's very difficult to see those points, pi fourths, pi halves, and so forth, and that sort of thing. Okay, but hopefully that gets you some insight. Now, the same techniques are used for cosine and tangent, and we'll try to visit those in a separate video.